Milwaukee Flooding 2025, Data, Science, and the Climate Connection. August 2025. Milwaukee, Wisconsin is drenched by one of the heaviest rainfalls in its recorded history. Within hours, roads turned into rivers, power lines fell, and thousands were stranded. In this video, we'll break down exactly what happened, how the numbers compare to past floods, and whether climate change may have loaded the dice for this disaster. Event overview, August 9-10, 2025. Rainfall total in Milwaukee, 5.74 inches, 146 mm in 24 hours, the second wettest day since record-keeping began, surpassed only by a 1986 storm. Peak localized rainfall, 10 to 11 inches, 254 to 279 millimeters in southern Milwaukee County and parts of Waukesha County. Rainfall intensity, in some bursts, 1.5 to 2 inches per hour, rates that overwhelm most urban stormwater systems. Power outages, up to 47,000 customers affected. Emergency impact, hundreds of vehicles stranded, dozens of water rescues performed. Key disruption, Wisconsin State Fair's final day canceled, along with major events like the Lynyrd Skynyrd concert. The meteorology. The flooding was triggered by a slow-moving mesoscale convective system, a large complex of thunderstorms that continuously regenerated over southeastern Wisconsin. Atmospheric precipitable water, PWAT values, were recorded at 2.1 inches, about 175% of August's climatological average, meaning the atmosphere was holding nearly double the normal moisture content. A stationary frontal boundary acted as a conveyor belt, funneling moist, unstable air from the Gulf of Mexico directly into the region. Wind shear and low-pressure convergence kept the storms from moving quickly, resulting in training echoes, repeated storms passing over the same areas. Hydrology and AMP infrastructure. Milwaukee's combined sewer system can generally manage a 1-inch rainfall over 1 hour without widespread flooding. With rainfall rates up to 2 inches per hour, water overwhelmed inlets, causing pluvial flooding, where rainwater can't drain fast enough in urban environments. Combined sewer overflows, CSOs, were triggered, releasing stormwater mixed with untreated wastewater into local waterways to prevent backups into homes. The Milwaukee Metropolitan Sewerage District, MMSD, confirmed multiple CSO events during the storm, something that last occurred at this scale in 2010. Historical context, 1986, 6.81 inches in 24 hours, still the wettest day on record. 2010, July storms brought up to 7.5 inches in parts of the metro, causing $37 million in damages and 1 fatality. 2025. While total rainfall was less than 2010 in some areas, the intensity per hour and impact on urban events, like the State Fair, make this event a standout in modern Milwaukee history. The climate connection. Trend. Since 1950, Wisconsin's average annual precipitation has increased by about 15%, with the heaviest 1% of rainfall events becoming 35% wetter. Warmer air holds more water vapor, about 7% more per degree Celsius of warming, Clausius-Clapeyron relation. Attribution science suggests that in the U.S. Midwest, climate change is increasing the likelihood of extreme rainfall events by 30–50% compared to the pre-industrial climate. While this event hasn't yet been formally attributed, it fits the statistical pattern: warmer summers, higher dew points, and heavier downpours. Impacts on public safety. Swift water rescues saved multiple drivers trapped in submerged vehicles. Economic hit. State Fair cancellation cost vendors an estimated $2.3 million in lost revenue. Health concerns. Standing water in summer can increase mosquito-borne disease risk, and CSO events raise bacterial contamination levels in rivers and Lake Michigan. Preparing for the future. The city of Milwaukee has been investing in green infrastructure, rain gardens, permeable pavements, and expanded stormwater tunnels. But design standards often use historical rainfall data, which may underestimate future extremes. Experts recommend updating urban drainage designs to withstand 100-year storms, that may now occur more frequently than once a century. Community preparedness includes flood insurance awareness, real-time flood alerts, and public education on avoiding flooded roads. Conclusion. The August 2025 flood was a product of meteorology, geography, and infrastructure limits, but also part of a bigger picture, a warming climate where extreme rain is more common. Whether you see it as a freak storm or a warning of the future, one thing is clear: preparation and adaptation must keep pace with the climate we're living in.